Okay, in yesterday class, we discussed about OSPF lab, and today we're going to see the Eigrp lab. Let's configure an Eigrp. Let me open the packet tracer. Just like yesterday, we're going to do 2 buildings, and we can connect them using the Eigrp. Yesterday we used a similar topology. Today we'll take one PC from one building and a different PC from a different building, and then we can have them connect using the Eigrp. So let's do that. Let's say on the left hand side is the building 1, on the right hand side is the building 2, and this is all one single company, and that company can be written as, let's say company name will be tech, and the AS number. What is AS number? AS number is nothing but the value that will be same on all the routers in the company, which are controlled by single admin. So in this company, we are using AS number 10. You can use any AS number, but in your company, all the routers will have one AS number so that they all part of one company. So here in this case, I'm using AS number 10. AS means autonomous system. AS autonomous system number is 10. Okay. And let's connect these two. Okay. So now let's go to the PC and let's do the configuration for this, right? So let's write the configuration. So this will be 10.0.0.1. This will be 10.0.0.5. And this is let's say we did 30.0.0.5. Oh, sorry. Right, and then this will be 30.0.0.1. This will be 20.0.0.1. And this will be okay. So we wanted to pick 10 from 10.0.0.0.5 to 30.0.0.5. We wanted to make them communicate using Eigrp between them. So that is our lab that we wanted to use, that we wanted to ping from PC0 on the building 1 to PC1 on the building 2. So now let's go to PC0 and then configure the default gateway and then ping the default gateway. Okay, let's try that first. So the IP address will be 10.0.0.5. Submit will be just fine. Then if I go to the default gateway will be 10.0.0.1. Okay. Now let's go to router 0. Go to CLI. Router, let's change the host name of this one. Host name. Oh, I have to go to configure mode. Configure terminal. Meaning I'm trying to configure something on the router. On this router, I'm going to do host name. I want to change the name of the router. I want to yes, building 1 router. Okay. I want to configure the interface. Gigabit 0.
Recording in progress.
0/0/0. I wanted to go to that interface and then I have to define the IP address as 10.0.0.1. If it is here, the subnet mask will be 255.0.0.0 because this is /8. Okay, I'm gonna do no shut. After I do the no shut, this red color line should be green and I should be able to ping between PC0 to the router. Okay. If you see the line protocol interface gigabit 0/0/0, change it to up. Okay, so now it is up. I'm going to do copy running startup configuration. I was able to copy the configuration. So now let's look into the configuration. Show run interface gig. Oh, I cannot do that. If I do show run configuration, that will give me the configuration of the entire device. So I can go to this interface gigabit 0/0 and then 10.0.0.1, 255.0.0.0 is the subnet mask. I configured that. The speed and duplex are auto, which is by default comes, right? That one is good. So now let's check the ARP table. Okay, now the ARP table is learning only on the interface. Okay, now let's try to ping 10.0.0.5. The first packet will be a broadcast packet, so it will fail, and all the remaining 4 packets are working fine. So now let's look at the ARP table now. So if you look into the ARP table, you see 10.0.0.5 and the ARP to MAC binding. This is the MAC address, and it is the ARP protocol, right? It's running by gig 0/0/0. So we know we were able to ping here. So now let's do the same thing on building 2. Let's do Eigrp This is what is this batch? My batch. Okay, so I'm gonna go to PC1. Go to config, go here, define 30.0.0.5. Okay, and also I have to configure the default gateway, which is 30.0.0.1. Okay, so the PC side configuration is done. Okay, now go to the router. CLI. We'll do enable and then configure terminal. I went to configuration mode. Now here I wanted to do host name and then building to. Okay, I have to go to interface gig 0/0/0 IP address as 30.0.0.1, which is the IP address of the interface, which is the default gateway, and I have to define the subnet mask. Yeah, and I have to do no shutdown. This link between the building to router and the PC should come up. Okay. So now I can do copy, running, startup configuration. So I'm saving the configuration. The configuration build is completed. So now you see the link is up between them. So now let's try to ping 30.0.0.5. Yeah, I was able to ping between the router and the PC. So this ping is working, and also this ping is working. So now let's make these two communicate, and then we'll turn on the Eigrp between them. Okay. Okay, I'm gonna go to interface. So let's see what our interface show IP interface brief. So I have 0/0/0/0 is already done. I have 0/0/1, right? So I'm going to configure this interface, which is connected between them. So I can do config terminal interface gig 0/0/1 IP address as 20.0.0.1, then 255.0.0.0. No shutdown. Interface is up now. So now let's log into other router. Which is the building to router. I'm going to go to here and then create interface gig 0/0/1 IP address 20.0.0.2 255.0.0.0. Then do no. So if you see the link between these two came up. Now let's see we were able to ping on both sides or no. Okay. So now let's go do ping 20.0.0.1. Okay, I was able to ping. Now let's go here and then try to ping the 2.0.0.2. I was able to ping between both of them. So I was able to ping between these two, both the routers with the connected routes. I can able to ping between the PC0 to PC1, which is the default gateway, and the PC1 should be talking to the router 1. So now let's look into the route table of router 0, and also let's look into the route table of router 1. Okay, let's look into that. So I'm on the building 1 router. If I do show IP route, So if you see, the 10/8 is the connected route, which is a 0, which is connected by a 0/0/0, where it is connected, it is learning a 10/1, which is the interface, which is L. L means local route. So this is a local .1 is locally configured on the interface. Similarly, 20.0.0.1 is configured on the interface, which is on gig 0/0/1. It is a local route. And this 10/8 is a connected route, meaning any interface downstream will be connected using this 0/0/1. Okay. Any questions till this point? Is it clear, guys? Yes, no? Sudhir, are you guys following me?
Yes.
Guys, are you guys following me or no? Because I want to understand. Are you guys able to understand what I'm doing today in the lab or no? Is it like,
Sir, is it same as OSPF lab?
yeah, it is same as OSPF lab.
Yeah, because I felt the last class also the same, like the lab yesterday.
Yeah, I wanted to make sure that you understand the lab. That's why I'm doing the same topology. But instead of OSPF, I'm going to do the EIGRP between the buildings.
Yeah, okay, yeah,
Today, between the buildings, we did OSPF, right? We are doing EIGRP today between them.
okay, yeah. It's clear, sir.
Okay.
Thank you.
Okay, so on the building one, router one, I'm going to configure. So I'm going to do router EIGRP, and I will do the autonomous system number. As I said, I'm doing autonomous system number means the company will have one autonomous system number, right? So I'm going to use my company number as 10. So now that means that I'm turning on EIGRP. So here in my building, I have two networks. One is 10 dot network and the other one is 20 dot network. So I'm going to advertise them into the EIGRP. I'm going to do network 10.0 because that is part of my network. I can define my wildcard mask. Yesterday we discussed about having a wildcard mask, right? If I don't put the wildcard mask, it will automatically calculate the wildcard mask for me. It will be summarizing that automatically. So I'm going to simply do network 10.0.0.0 and then I'm going to do network 20.0.0.0. So this is what I have on the building one on the EIGRP side. So I'll go to building 2 router and then do the EIGRP configuration there. Okay, so on the building router, configure terminal, router EIGRP 10, and I own 30.0.0.0, then I own 20.0.0.0. Once I turn on that, you see EIGRP is up with a new adjacency. So we have an EIGRP neighborship between these two routers, and I can check show IP EIGRP neighbors. If I do show IP EIGRP neighbor, it will give me the neighbor IP address through what interface I am forming a neighbor. What is uptime? It is up from 22 seconds. And the whole time is how much time I should wait for the neighbor to go down, and then I have to hold for my hello packet to receive, right? So that is that. And the other sequence numbers are common in both the protocols. So also do show IP route. You see, I'm on the building 2 router, but I'm learning 10/8, which is in the building 1 network via D. D means, if you look into the index here, D means EIGRP. So D means EIGRP. So I'm on building 2, I'm learning 10 network via D, which is the EIGRP route. If I go to building 1, I have to learn 30 network via EIGRP. So now let's go to building 1 and then do show IP route. See, I'm learning 30 network via D, EIGRP. So two networks are there, and we did a EIGRP between them, and they were able to learn the building routes on both sides. Okay. So now let's try to ping between them. I want to ping my gateway first, 10.0.0.1. I was able to ping it. Now let me try to ping something on the other building. I want to ping this router interface, 30.0.0.1. I want to ping that, okay? 30.0.0.1. I was able to ping the other network. Now I want to ping the 0.0.5, which is the other host. So I was able to ping between them. So from building 1, from this PC, I was able to ping this PC in the other building by having an EIGRP between them. So I was able to ping between the buildings with the EIGRP link between them. Okay, so now let's look into the EIGRP commands. So to check the neighbor, we already know we did show IP EIGRP neighbor. Okay. So I can check EIGRP neighbors, I can check topology, and I can check EIGRP traffic as well. Now let's look at the EIGRP interfaces. If you see, I have two EIGRP interfaces, which is 0/0/0 and 0/0/1, because I have this building 1 router, right? So this is the building 1 router. I have 0/0/0, meaning this is a 10 dot network and this is 20 dot network. And I was able to have both of them in the EIGRP interfaces. If I do show IP EIGRP traffic, I will see how much bytes sent and bytes received. Hello sent, hellos received, reply sent, received. They all will be in the timers of statistics in the EIGRP traffic. But if you want to check the neighbors, as I mentioned, show IP EIGRP neighbors. So on the building 1, I was able to form the neighborship to 20.0.0.2 via the link between them. So I was able to form the neighborship between the routers with 20 network. So that is about the EIGRP lab and how we were able to connect two buildings between them. In the CCNA certification lab, certification exam, you will be not given any of the labs to make them ping between them. They will just ask you questions like, how do you check the EIGRP routing table? These are the options, select one. So it's a multiple choice questions exam, right? So, but you will not be assessed on the lab. Okay, now let's talk about, let me stop here. Any questions before I talk the cabling issues about the cabling and stuff that we missed day before class? We did stop at the last topic, right? So any questions before I start that?
No, sir.
I'm sorry?
No questions, sir.
Okay, yeah. Now tell me, like, what is the progress on the labs? Did you guys start downloading Packet Tracer or no? Not yet.
I'm Ranga, sir. I already have downloaded it, like to use it in my assignments, sir. So I already had it.
Okay, good. Have you done any labs till now?
Yes, like not after joining the class, sir. I did it when I had some assignments when I was doing networking in my college.
Oh, that's great, man.
Yeah.
That's nice. Good. I like people who comes from the university learning networking and come to a networking job. That is good. Okay, anyone else who tried packet tracer? Did you try any labs? Why everyone is so calm today? Is it like because of Friday evening? You guys are all tired from work? Okay, no one is willing to talk today to me. Okay, that's fine. We'll talk to the last topic. Okay, so we have to troubleshoot interface issues and cable issues, right? So there are different problems that occurs in the physical layer that we should be discussing in the networking, right? So now let's talk about that. Let me start sharing my whiteboard. So let's say, let's write it down. So usually there will be issues like collisions, errors, or duplex, or speed. Right? These are the most common problems, right? So what does the collision means, right? So for example, let's say there is a PC and there's another PC. Let's say there is PC1 and this is PC2. Okay, and they all connected like in the old topology, right? So they are connected like in this PC is connected to this NIC and this PC is connected to this NIC, and they try to send the data, and then this PC try to send data, and there is a collision, right? So collision is nothing but when two of the devices sending the packet at the same time and they collide, that is called collision. But in full duplex Ethernet network, collision detection is disabled, right? So it is disabled. So what does this mean is like, let's say this PC is sending the Ethernet frame, and at the same time this PC is sending the Ethernet frame, they got collided. What they're gonna do is they're gonna do a pause and go mechanism. So let's say this will send a PC1 will send the timer of like, for example, 4 seconds. It will pause for 2 seconds. In the meanwhile, the PC2 will send the data out because it paused. So this is called pause and go mechanism. It is called something like carrier sense multiple access collision detection, meaning like, let's write it down, CSMA or CD, which is nothing but it is a collision detection mechanism where if the PC1 try to send the data first, and for example, if it got collided with PC2, it senses there is a collision, right? It's a carrier sense multi-access collision detection. So when there are two carriers and both of them are sending the data at the same time, if they collide, they're gonna sense it, they're gonna sense the detection, and what they're gonna do is they will try to wait for a second or 2 seconds and then send the data back again. They're gonna retransmit. So this is the collision detection. If there is excessive collision detections, for example, this is gonna send the data, collide, and wait again and send the data out. So if these detections are like many times happening, there will be retransmission again and again, causing the network issues for the engineers or the users, right? Because there will be excessive collisions. Okay, so usually we will be avoiding this kind of topology in the first place. We don't want this kind of topology in the first place. For example, let's say this is a switch and this is a PC, and you have a router on the top, okay? And this is a full duplex network. What is full duplex, guys? This guy sending the data and this guy sending the data same time, right? So they're gonna use one single link to have channels between them. So switch will send the data and the PC will also send the data at the same time. That is called full duplex. What is half duplex? Switch sending the data in one direction and PC just waiting and listening. And when the PC sending the data, switch is waiting and listening. That is called half duplex. But in the full duplex, it's like if it's a switch and if it's a PC, it's consider this as a single lane, but there is separation between them. Switch can send the data in this lane and PC can send the data this lane. This is called full duplex. At the same time, you can send the data in two directions. But let's say there is an issue, like there is a bad cable here. So the PC send the data and the switch want to send the data in the same buffer. So there is a collision. So when there is a bad cable, you will see some errors causing the collisions in your network. So when your links are bad, the data might be going in one buffer over the other inside the same link, which will cause collisions in your network. So to avoid that, we will make sure we are using the fit good cables and make sure there is no collision between the devices. So that is called collisions. So basically, when there is a collision or when there is an excessive number of collisions, what we do is we will use a different port. We will ask the person on the site to clean the NIC and then place the interface back or change to a new cable. So we will replace the cable, right? Okay. And then what is error? Error means switch will use a counter, meaning, for example, there is a switch, there is a router, or there is a PC, okay? When the switch send the data, let's say this PC had a bad NIC, meaning like the bad interface. The interface went wrong, or interface, there is some water in the interface, or it is too dusty. Something bad happened, or the cable is like lightly broken. Okay, let's say this is an unshielded twisted pair cable, UTP cable, and the top layer is broken, and some of the bits are being broken here because the cable is like already broken a little bit. Switch send the data to it. It lost the data because some part of the cable is broken. It tried to resend it again. If this keep on happening, switch will have a counter called error counter. So this error counter will keep on incrementing because there is a packet loss. So the customer sitting behind the PC try to go to the, let's say, google.com. The google.com is here. Google. He will send the request. Sometimes it works, sometimes it doesn't. Right? So it's like a hit and miss. Or sometimes it takes too much time to load the page. It takes so much time to load a single page. That means that even though the google.com is sending the data to you, because of this packet loss is these errors. It's going to retransmit the data again and again. So that's why you will see the slowness. So that case, you can look at the switch port and errors will be incrementing. These are usually called CRC errors. Okay, CRC error means usually the switch is maintaining a counter. That means that the cable is bad, or the interface is bad, or the SFP is bad. The connector is bad. So as CRC stands for, so I click redundant. It's gonna send the meaning, like for example, if I send the data to you, to validate the data is being went all the way to the other side or not. If not, the CRC errors will increment. And when you as administrator, when you log into the device, and if you see the CRC are incrementing, you can obviously say that there is a problem with the physical layer. Physical layer problem. If the CRC is incrementing more and more on that interface, that means that there is a problem with the physical layer. The CRC counters will be incrementing, and then there is a problem with the physical layer. That is the issue that you can tell that you as administrator, when you log into the device, and if you see the CRCs are incrementing, that means that there is a problem with the physical layer interface or the SFP problem. Okay, now let's talk about the duplex. I think we already talked. Let's talk about the speed. Before we talk about the duplex, let's talk about the speed. So let's say there is an switch. And there is a PC. Okay, the speed of the NIC will be, the speed of the network interface card will be like 1 gig. The switch port should be 1 gig. If the speed is mismatching between these two, if this is not mismatch, if it is mismatching on both sides, the switch port will never come up. The switch port will not be up. You will see that it is administratively up, meaning you are trying to bring up but layer 2 is down. These two devices will try to negotiate the speed at the layer 2. If the speeds are not matching, the interface will never come up. Similarly, let's say there is a switch and there is a PC. Let's say this is full duplex and this is half duplex. You know what is the difference between half duplex and full duplex already, right? When PC is sending the data and waiting for the switch to send back, it will only work in one direction, that is called half duplex. But full duplex means sending and receiving the data at the same time. That is called full duplex. If there is a duplex mismatch on both sides, then the interface will not come up. So usually in the interview or on the exam, when you see that there is a speed or duplex mismatch, you should automatically select the interface will never come up, because there is a mismatch of the speed and duplex between them. That is one thing you can blindly think of. And also, if there is any network, if there is any slowness issue, or if there is any issue in the route transmission, to avoid the physical layer, we have to validate there shouldn't be any issues with the CRC errors, meaning there shouldn't be any issues with the physical layer. That is what we have to validate. So usually while troubleshooting, for example, let's say this is an app server. and this app server is connected to router 1, and there is a router 2, and this is connected to database server, and R1 is connected to router 2. Okay, app server is saying that, hey, I wanted to send a file or I wanted to get some data from the DB database, but the call is very slow. So you as a network engineer, you have to log into the router, check the interfaces between the app to the router 1 and the interface between router 1 to router 2 and the interface between router 2 to the DB. Make sure that there is no issues at the CRC errors or drops of the packets. So you can log into the router interface and you can do show interface and define the interface name. That will show you if there's any CRC errors or any physical layer errors. So let me share my packet tracer screen. Let me show you how it looks like. So if I go to this router and if I do this PC is controlled on 0/0/0, right? If I do show interface gigabit 0/0/0, you will see here 0 CRC or 0 errors. So this if there is an issue with the physical layer, you will see these errors will be incrementing on the interface level. That will indicate that there is a physical layer issue that you have to avoid in the network. So when someone complains, hey, can you check my interface? You have to log into the router and then check their interface to see if there is any errors or CRC that are incrementing to avoid any physical layer issues. Is it clear?
Yes, sir.
Okay. So with that topic is also completed, and we completed the labs of OSPF and Eigrp, and we are officially done with our classes and with this course. We have to discuss about IP address, that as I mentioned, that we'll do on Monday as our last class, and Monday will be the last class for this course. I'm gonna stop recording and leave the 10 minutes for any questions. Any general questions or any regarding the class or anything, we can wrap it up. Let me stop recording.